To solve another Leetcode problem, 2653, sliding Subarray Beauty. So we are giving an array nums. Inside the nums, it can be positive or negative integers, and we want to the array would the length of the result array would be n minus k plus 1, and we are also giving a window size, so the size is k. So for this example, k equal to 3. And we are also give another x. So this x means the x smallest integer. So for this example, for the first window, so this size is 1 minus 3. So the size of the window is k, is the second smallest integer. So the smallest is minus 3, the second smallest is minus 1. So that is why we're gonna have a minus 1. And for the second sliding window, so the second smallest would be minus 2. And for the last one, minus 3, minus 2, and positive 3. So the second smallest would be minus 2. So this is the result. Yeah, as you can see, according to the description, this kind of problem is a sliding window problem. And also we can check it from the title, sliding Subarray Beauty. Yeah, so the beauty is the conditions for check for the k and x. So, and the window is also size, is also fixed. So for the size of the window, so we can use a if inside the template. Yeah, basically. And also inside the window, we need to sort the array. But if we are going to sort the array, it's gonna be k log k time complexity. But we want to reduce it to log k time complexity. So how can we do that? We can use some data structures in Python. So that is a sorted list. So I'm gonna use a sorted list from sorted containers. I'm gonna import the sorted list because I want to have the list sorted. So for this example, minus 1, minus 3, minus 2, I will let it be sorted and I can get the second smallest integers. So that is why. Now I'm gonna prepare a sorted list. And for the L pointer, L index, and result. So for the L index, it would be start from 0, and the result would be. Now I can enumerate the right index. So for Rn in enumerate nums. Now I can start the sliding window template. Yeah. First of all, I'm gonna put the numbers inside the sorted list. Now, because the window size is fixed, I can use if to check. So if the length of the sliding window is more than this k, it means it is too big. So the window is broken. So I need to fix it. Yeah. So the SL should remove from the left side. So it is nums L. After that, so L would plus equal to 1. So the left side, the window from the left side would be shifted to 1 to the right side. Yeah. Now I need to check if the length of the sliding window is equal to k. Why I need to check it? Because from the beginning, for example, the window size is 1, and then it becomes 2, and then it becomes 3. So that is why I have to check. Yeah, if it equals to k, now I have to check the second case. Now inside the sliding window for this x minus 1, so it means it is the x smallest integers. So if this integer is less than 0, I can put it inside my result array. So it would be SL sorted list x minus 1. So if it is not according to the description, I'm gonna have a 0. So result would append 0. And finally, I just need to return the result. Yeah. So this is actually the entire code. As you can see, it is not so difficult by using the sorted list from the sorted containers in Python. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed, although it is not so fast because this is a n log n time complexity. Basically, this n is the nums length, and another n it is actually k. So n log k is less than or equal to n. So basically, it's similar to n log n. So that is why it is a little bit slow compared to O(n) time complexity. Yeah, but I believe the O(n) is a little bit harder than this kind of method. This kind of method is more intuitive and it's easier to understand. And this sorted containers, the sorted list is very useful to solve especially the medium and hard problems in Leetcode. Yeah, now let's analyze a little bit about the time complexity. So this is just O(n). And for here, the sorted list add and the and yeah, let remove. So yeah, the operation is similar like a set operation. Yeah, because the sorted list have the property of array of a sorted array, but actually it only takes the log n time. Yeah, so that is why the SL used add and remove.